Okay, here we go. What I'd like to do today is go ahead and cover the quiz over rational functions. So if you've been following along as far as my class, we just did a kind of like a mini lesson and doing a little live stream a little bit later than I normally do after school. And I do kind of know it's Halloween, but we already got our candy. And so I am all ready to kind of get through this quiz because my students are going to be taking a test tonight. So if anybody is going to be joining us, I'm not expecting many people, as I know a lot of people are going to be out and about and in a little bit of a candy binge. Well, that's cool. I need to kind of work through this document, so therefore I can provide it for my students. So that's exactly what I'm going to do. But if you are kind of joining or you have some questions on anything that I am covering in this quiz, or just in your class, what I will do is, like on my other streams, I will kind of work through these 4 free response questions. And then what I'll do is take a nice quick little break and go ahead and get to some multiple choice. So, hey, Miguel, how are you, man? I'm glad you could kind of join. Looking forward to doing a late live stream compared to some of my earlier ones at school. So I am at my house now. I am working on getting a setup. So I have a setup at my house as well as at school. And therefore it's just a little bit easier for me to kind of stream based on what I'm doing. So, hey, Layla, how are you? Help have a D in algebra. Well, Layla, if you have some questions over what you're going over, I will be taking a break, as well as after I work through this quiz. I'll be more than happy to help help you with any kind of questions. But obviously answering specific questions is not going to give you a magic pill, doing better. There's definitely some other things we'll want to do to get you set up for success. Can I ask, Miguel says, can I ask, it's a lesson about our lesson regarding on random variables. I probably won't be able to answer regarding random variables, but I don't know. You can go ahead and please feel free to ask. And, if I can't answer it, or if I feel like I'm just not prepared on the middle of the live stream, then I'll just tell you that, and, we'll go from there. But yeah, please feel free to ask. I'm going to go ahead and get started on this quiz because most people that are coming to this either on the replay are going to be looking for me getting to the quiz answer. So I'm going to get to that. I'll take a break though, Miguel and Layla. And if you guys have any questions at the mid break or at the end, just ask and I'll be happy to help you out with that. So, rational functions quiz. Oh, there we go. Let's go and use Brown. Don't use Brown a lot. I'm going to start this one. This is going to be a Brown quiz. All right, so basically what we're looking into is simplifying the expression. And the main idea when we're simplifying is applying the division property. Excuse me. And the main important thing about the division property that we need to understand is the division property only works when we have terms separated by multiplication. So you can see these terms are separated by multiplication, so that's B. It does not work when we have terms separated by addition or subtraction. Okay, that's it. You can't, that does not equal B. Okay, so a lot of students get used to this division, we just kind of put a line there. You can't do that when you have terms separated by addition or subtraction, only when you have your terms separated by your multiplication and division. So what we look at here is we see that every term, except for the 2 and the x, but every term here is separated by subtraction, or addition. We could rewrite this. And our main goal is to rewrite things as multiplication. And again, the process of rewriting an expression as multiplication is called factoring. Now, this up here I have a quadratic trinomial, and I can recognize that to be able to do factoring. But in this numerator, I might be a little denominator, I'm sorry. I might be a little confused as far as what I want to do for that. So what I'm going to do is I'm just going to rewrite that as a negative x squared plus 1. And just by rewriting that, I'm still still not kind of getting it, right? What else, how else could I rewrite this? Well, then I realize if I factor out a negative, I would be left with a negative, if I factor out a negative, I'd be left with an x squared minus 1. Again, I'm not changing the value of this, right? I just, first step, I just switch the variables, and then second step, I just factor out a negative. But if you multiply that negative back and rearrange back the variables, you're getting the exact same, expression. So what I'm going to do is, this is a little bit easier to factor because I notice the difference of 2 squares. So I can go ahead and factor this numerator to x minus 3 times x plus 1. And then I can factor out the denominator as a negative x minus 1 times x plus 1. Now you can see that I have terms separated by multiplication, right? So now I can apply this division property. I can divide out the x plus 3's, and we put these lines, but really they're just multiplying to give us x plus 1. Now, again, the next thing is doing this negative. Like, where does this negative go? It doesn't matter. The negative can go in the denominator, the numerator, or right out front. It's usually just kind of best practice to, put it out front, but it really doesn't matter where you want to put that. So we could just rewrite this negative x minus 3 over x minus 1. And again, like my rule that I like to do with students is, negative 4 divided by 2 is equal to 4 divided by negative 2, which is equal to a negative 4 over 2. Or let's put that negative, put the negative right in front there. But that is not equal to a negative 4 over negative 2, right? So you can't put the negative both, but you can put it out in front. You can put it in the numerator, you can put it in the denominator, just not in both, okay? So that is just a quick little review for you. And then I also talked about the discontinuities, but I told my students, don't worry about discontinuities. We can rewrite that as, I meant to say, identify the restrictions. So when looking at the restrictions, basically what we're doing is we're looking for the values of x that x cannot equal. And here we can see that x cannot equal 1, but again, just because this x plus 1 got divided out, that doesn't mean that's not a restriction of the original problem, because you can see if you plug in 1 or negative 1 in the original problem, you would still have 0 in the denominator. So I will just add that, where x cannot equal plus or minus 1. All right, in next example here, just asking for you to simplify the expression, not worry about the restrictions on the variable, or simple restrictions on the expression. And what we did is we kind of talked about two different ways, of looking at this problem. Immediately, I see a quadratic, and I say, you know what, I'm going to go ahead and factor that out, because I can see that this can be factored into, it looks like the product of our two other denominators, x minus 3 times x minus 1. All right, so now I'm looking at, I have three different types of denominators. I have x minus 3 times x minus 1, I have x minus 3, and I have x minus 1. If I'm looking for the common denominator, I notice that this times this equals that, right? So it's really kind of like, 12 minus 2 over 6 over 3 over 2, right? This times this equals that, right? Like 2 times 6 equals 12. This times this equals that. And the way to get rid of fractions on a problem like this or a problem like that is just to multiply by the LCD. And you could also get common denominators and then take the numerators, but that's the exact same thing that I'm doing here. I like to just multiply by the LCD because to me it's a little bit less work. Even though I think that common denominator, getting the common denominators is sometimes helpful when you struggle with identifying the LCD. Getting the common denominators is a helpful method. But now I'm going to multiply this times every single product. So when I multiply this times that, you can see that x minus 3 and x minus 1's divide out, so therefore I'll just be left with a 1. When I multiply this expression times 2 over x minus 3, you can see the x minus 3's will divide out, and I'll be left with a negative 2 times x minus 1. And then when I multiply x minus 3 times x minus 1 times this expression, again the x minus 1's will divide out, and I'll just be left with a 3 times x minus 3. Okay, now I can apply a distributive property here, and I'll just kind of work my way to the right. So this would be 1 minus 2x. Again, make sure you're distributing the negative 2. That's going to be plus 2 over, let's distribute here, 3x minus 9. And then I will just simplify one more time. Let's just add the 1 and the 2, so that would be a negative 2x plus 3 over 3x minus 9. And there you go, done. All right, working on the next one. This would be typically one that we'd be looking to graphing, but I didn't ask my students to go ahead and graph this. I just wanted them to work on finding the horizontal, vertical asymptote, slant if it's there, as well as the x and the y intercepts. So the main thing I noticed with this one, though, is factoring. We can look at, always want to, for all these problems, look at the factoring. Try to factor. And so in this numerator here, I realized that I can factor out a 3x. By factoring out a 3x, I'm left with a x minus 1. In the denominator, I know that I have a trinomial. If this is factorable, it's going to be a product of two binomials. So that's going to be a 2x, and that would be an x. Let's see, I'm going to add two numbers that multiply to give me 1, but the middle terms is going to be a sum, and they both need to be negative since the middle term's negative. So therefore, I can see that it's just going to be -1 and -1. It's pretty simple to easy. But the important thing here is I just rewrote this as a product, right? I just factor this. So you can see that I can divide this out. Now, when we're identifying discontinuities or talking about asymptotes and intercepts, it's very important for us to understand that there is a hole at x is equal to 1, right? Because when these divide out, that makes a hole. The discontinuity is when x is equal to 1, because when x equals 1, that would make that 0. But it gets divided out, so it's a hole. Now, I didn't ask anything about the hole, but that's very, very important information for us to kind of hold on to, because what we want to do now is identify the vertical and the horizontal asymptotes and kind of see if the hole is going to come back into play. So my students did not need to talk about the hole at all. But I did want to see their work. I was looking for them to either show them dividing that out or them to be simplifying that as evidence that they have identified that as a whole. Well, they didn't even need to. It's still they needed to get the right answers. So the first one was just looking at the horizontal asymptote. And this one's fairly basic. You can see that the degrees in the numerator and the denominator are exactly the same. So therefore, we are looking at a ratio of the leading coefficient over the leading coefficient. So the horizontal asymptote is as simple as y equals 3/2. The vertical asymptote are the values in the denominator that make the equation equal to 0. But it's very important here because we realize, well, x minus 1, when x is equal to 1, that makes it 0. But that gets divided out, so that's a hole. So it can't be an asymptote and a hole. We talked about that in Chapter 1. You can't have an asymptote and a hole that are for the same value, right? So if it is a hole, then it's not going to be at a asymptote. So that means my only vertical asymptote is at 2x minus 1 is equal to 0, or x is equal to 1/2. For my x-intercept, that is, when y is equal to 0, solve for x, in which we talked about in class. You can really just set your numerator equal to 0. But again, at x minus 1, I don't need to set that equal to 0 because that's already a hole. You can't have an x-intercept at a hole. A hole is an undefined value. So all I need to do is just set 3x equal to 0, and I can just say x is equal to 0. Right? I don't need to set the x minus 1 because that's a hole. You can't have an x-intercept at a hole. And then y-intercept is, again, the x, the y values when x is equal to 0. So you'd plug 0 in for x, but what we noticed that was constant over constant. We notice that there's no constants up there, so that y-intercept is 0 over 1, which is y is equal to 0. Boom. All right, let's go back to brown. What happened to brown? I like brown. All right, next one, solve the rational equations and label any extraneous solutions. So in this one, I am going to appease some of my students that have been using a different method than what I have taught, but I am going to, again, apply the reasoning behind their method and why it kind of works. So kind of like what I did here in the complex fraction, I need to identify the common denominator, right? And I see that I have a quadratic trinomial. I'm going to want to factor this to x minus 4 times x minus 2. Now, again, just like the previous example, I realize that that is my common denominator. In my method, I would just multiply everything by that common denominator and simplify. Some of my students have, figured out that an easier way to help them do the exact same process is to find the value that's going to multiply in the numerator and denominator that gets common denominators. So therefore, you can say x minus 2 over x minus 2. So basically what they are doing is they are getting common denominators, kind of like what we had to do when we did addition and subtraction. But my thinking is most people hated adding and getting common denominators because it's just more work. But what's nice about this is now you have an equation where all the denominators are all the same, right? And just remember, if you're going to do that, you have to make sure you multiply the numerator and denominator. So now once they have that, they can just write the numerator. And the reason why they can just write the numerator is because technically what they are doing is multiplying everything by the common denominator, which was my first step anyways. But again, sometimes if you don't understand how to get the common denominator, I like this method. I really do. So you multiply everything by the common denominator, and you can see that all these denominators would divide out. And therefore, I am left with x times x minus 4 plus 1, I'm just going to put it for accounting purposes, times x minus 2 equals 2, right? So all these denominators will divide out, and that's what I'm left with. Now I'm just going to have to use a little distributive property. So x2, I don't need distributive property there, so I get x squared minus 4x plus x minus 2 is equal to 2. And here is like the main thing that I had when I've already graded like half the class. The main thing I saw in this case was a lot of students just stopped here. They didn't know what to do. And it kind of actually surprised me because I really thought we discussed a lot of this in class, that students wouldn't get tripped up on the Algebra 2 portion, or even the Algebra 1 portion of the problem. And, basically, you should recognize that the higher power here is 2. And we've already worked on solving polynomials, and solving functions. So I was really kind of surprised a lot of students got tripped up here because we recognize this is a quadratic with more than one variable. We need to set this equal to 0 and then look at either factoring, completing the square, or the quadratic formula. And by combining like terms here, go back to brown. Why am I losing brown? So I subtract a 2 on both sides. I can group these because these are like terms. And then I obtain, I'm going to do this work over here because I ran out of space. I obtain x squared minus 4x, no, not minus 4x, minus 3x minus 4. And then that, since you subtracted 2, that's now going to be equal to 0. Okay, so now we get to solve, and we got to pick our method. Well, immediately I'm looking at this, and I say, oh, this is factorable. I can factor this out as x minus 4 times x plus 1 equals 0, right? And therefore, using the zero product property, set them both equal to 0, x is equal to 4, and x equals negative 1. But we also talked about a class, and I also talk about label any extraneous solutions. And again, the basic definition of extraneous solution is a solution that is a solution of a simplified equation, but not the original. And you can see that when we have this quadratic, right, if I was going to give this quadratic to an Algebra 1 or an Algebra 2 class, they would solve this. They would get those two solutions. And if you plug these two solutions back into that equation, they are going to make that equation true. However, when we take these two solutions and plug them into this equation, you can see that 4 makes this denominator equal to 0, and that is not, you cannot divide by 0, and that's not going to work. It's not going to equal, it's not going to be the same on both sides, so therefore, this is called an extraneous solution. It works for a simplified equation, but not the original. And so that's basically what we needed to identify there is not only solving the equation, but also identify the extraneous solution. Again, a solution to a simplified equation, but not your original. All right, so I'll take a quick little break, check in with you guys, and if you guys want to kind of work on any of these multiple choice ones, they're up there. I'll go ahead and check out who wants to join on a lovely Halloween evening. Hopefully you guys got some candy and everything else. Miss Unicornia says m equals 3n equals p over 4 equals q plus 5 over 7. I need to find the variable that has the greatest value. I am not really sure. That kind of seems a lot greater than 0. I guess I'd kind of need a little more context. I'm not really seeing how I can address the question based on what you have. So sorry about that. Check the third page. Some is trig, but the idea is the same. Oh, arguments. It's really hard to explain over text. That's a bit more to way I taught and to multiply A and C, the first coefficient and last. Arguments is talking about using the AC method, which is like perfectly fine. Sorry, I guess I could have scrolled back up there. But yeah, like as far as factoring quadratics, it's in Algebra 2, I teach the factoring quadratic kind of method, or factoring the AC method, multiply 2 times 1, and then you get there, and then you can factor by grouping. By the time we get to pre-calculus, I need students to be able to really kind of identify this, and what I have found is most students still cannot factor. So I think about it, it's like we spent so much time teaching students how to factor, how to understand factoring, and they still struggle with it, right? And I know that for sure. I've struggled, when I was learning factoring as well. So what I've identified, or the way that at least I kind of teach it in the pre-calculus level, I still believe in the Algebra 1, Algebra 2 level, there is some idea of, as far as understanding how the factoring works, or learning some different techniques, because unless you have the number sense, you need to have some skills to be able to factor, and the AC method is great for that. However, by the time students entering pre-calculus, which is the way I'm teaching this, and students need to have these patterns kind of down by now as far as the factoring. Otherwise, it's really going to inhibit them being able to do a lot of the math work that is required in pre-calculus and above. So I talk a lot about the patterns, and the way that I explained this problem was, you know that the last two, like we had 2x and x give you 2x squared, and we know that the last two terms have to give you 1. So and since it's a positive one, it's either positive 1 and positive 1, or negative 1 and negative 1. So that's what I call a sum. You're adding 2 of the same values, positive, positive, or negative, negative. And then I look at the negative term, and since it's negative, I know that those 2 values have to be negative. That's why I got negative 1, negative 1. And if you are more curious, I do have a worksheet on this, which has a ton of factoring problems that really kind of drives home that idea. All right, what's the best way to factor polynomials? Well, hopefully that was just kind of a little bit, but fluffy cow cheese. If you, I do have a worksheet that I just kind of came out with that I sent over last week to a lot of people that are on my email list and people that are on my Patreon account and channel members. But if you want to go and take a look at it, just send me a message and I'll be more than happy to send it over to you. You don't need to join anything if you'd like that content, even though those are kind of the platforms that I distribute a lot of the content that I create. But obviously, I think that, feel free to message me and I'll give you a copy, because I think it really is something that helps students understand their, factoring, and so on and so forth. So, hola, my lost father. Just want to take text says, you owe me so much. Happy Delta. That's awesome. Miguel, cancellation. How'd you factor the top? All right, well, I guess I'm going to go ahead and get this going. I'm doing domain and range of the function. Layla, I have a lot of videos on domain and range of a function. So if you go and check that out, I will definitely get to it. Secant times secant minus 5 is equal to 0. Orange Butts asks that. How much is the copy? The copy's free. Free. So don't worry about it. People that supported my channel on Patreon have given me the value for me to be able to provide this out to you guys for free. So I really, really appreciate the people on Patreon for helping me do that. What I will do actually is after I'm done with this, I will post this on my community tab, my public community tab, not the private community tab. So I'll post this on the public community tab. So therefore, you guys can get a copy if you're not on my if you're not receiving any emails from me or not in one of my memberships for Patreon or stuff like that. So I'll go and post that for you guys so you guys can go and take a look at it. Cammy the Savage says, no, I'm a pre-calculus teacher, actually. I've taught Algebra 2 for many years, but I'm teaching pre-calculus this year. So anyone geometry, it's factor by grouping. But yeah, factoring, it's confusing. It takes some work, definitely. All right, let's go over these word prompts to finish up the quiz, and then I'll get on with the rest of the kind of comments for you guys. Even though, let's see, 9:45, it's going to, so, all right, working on the brown. So given the equation, find the oblique asymptote. Remember, guys, oblique is going to be the same thing as a slant. The main thing I want to do is just make sure that if I don't have a slant asymptote, that means this is a hole. But I see that this is not going to be factorable, so the x minus 8 is not going to divide into that. It's not going to factor and divide that out where it's a hole. So therefore, I can identify the slant asymptote by using long division. So again, the slant asymptote is the quotient of division for x minus 8 divided into x squared plus 9x minus 6. So x goes into x squared, x times x is x squared. X times negative 8 is a negative 8x. Okay, we're going to group our terms and subtract. And in this case, that goes to 0. 9x minus a negative 8x is a positive 17x. X divides into 17x, a positive 17 times. And again, what we talked about in my class is we're only going to be working with our asymptotes, that are going to be in a linear form. So you can see here, that is my quotient. So it'd be y is equal to x plus 17, which is answer A. Letter 6, or number 6. It says, let f of r equal r squared plus 5. Which one of the following statements is true? R squared plus 5 divided by 12r squared minus 7. Okay, so it says f of r has exactly 2 vertical asymptotes. Well, again, nothing can be factored out, right? I'm not seeing any factoring that's going to happen. So for this one, I would have 12r squared minus 7 equals 0. And what I notice is if I add 7 divided by 12, I would get r squared is equal to 7/12. And if I take the square root, I have to include plus or minus. So that looks like that's true. Let's just make sure there's nothing else that would make sense. So therefore, r is equal to plus or minus the square root of 7/12. Okay. So the domain of f of r is all real numbers. Well, if that means this domain of f of r is all real numbers, then that means r could equal plus or minus square root of 7/12. But those are the values that actually make the denominator equal to 0. So that one's not true. Y equals 0 is the horizontal asymptote. Well, that's not true because when the degrees are the same, the horizontal asymptote is y is equal to 1/12. So it's not B. And then FR has a slant asymptote. No, if it has a horizontal asymptote, it can't have a slant. So the answer in this gun is A. Number 7, it says list the intercepts and the type of symmetry, if any. So obviously the intercepts is referring to the x and y. And obviously I can see if I plug in, 0 in for y, set in the numerator equals 0, I'm getting 0. And for the y-intercept, I plug in, 0 in for x, I get 0. So it's not going to be C. The next thing I got to do is test the symmetry. And if you remember in function notation, we tested symmetry by plugging in f of negative x. All right, and again, if we got f of negative x, we got back the original function, it was even. If we got back the opposite function, let's do it this way, f of funks, that's even. And if we plugged in f of negative x and got opposite of f of x, it was odd. I don't like how I've written that, so let's do that one more time. It would be odd. So what I'm going to do is, again, I'm just going to replace the y with an f of x. So I'll do f of negative x is equal to a negative x to the 5th over negative x squared minus 6. So you can see here, negative x to the 5th, anything negative raised to an odd power is going to be negative. Negative times negative is a positive. Okay. And then here, that's still going to be positive, so that's an x squared minus 6. So now you might say, okay, well, that's not the same, right? Because this has a negative that's in, but is that opposite? So it's kind of confusing, actually. And so one of the things I like to do is rather than trying to go from here to here, I think it might be easier to go from here to here. And this is what I did. I looked at this and I said, all right, well, what would happen if I pulled the negative out in front? If I pulled the negative out in front, then I'd be left with a positive x to the 5th over x squared minus 6. And what you can see is that's the same as what I have here. So you can see this is opposite of that function. So therefore, or opposite, that is going to be the opposite of the function. So therefore, you can see that my answer is going to be with respect to the origin, which is going to be odd. For number 8, we're going to find the vertical and horizontal asymptotes. Remember, the vertical asymptotes are the values that make the denominator equal to 0. So you can say that's x is equal to 5. So immediately I'm looking for anything that does not say x equal 5. That one and that one. Okay. Horizontal asymptotes, remember, these have the same degree. So therefore, my y is going to equal 2 over 1, which is just 2. So I have these two. You can see that the only one that has y is equal to 2 is right there. And then last but not least, and I'll get into your questions, is find the horizontal asymptote, if any, of the graph. You can see that the degree in the denominator is larger than the degree in the numerator. No math was required, just had to go and select C. So there you go, ladies and gentlemen. That is my rational functions quiz for today, and we will be working in on a test for the class. So I hope you guys went ahead and enjoy. Let's see. I got a little bit of time, just kind of see what questions I can maybe answer from you guys that have been staying with me so far today, and help you guys out. So Ashwin says until 10 doing live streams on quiz answers. Yes, thank you. That's exactly what I'm doing today. Taught better people meditation. Well, appreciate it, man. I appreciate it. Happy to help. Can you help me with linear equations? Commando, yes, I can with linear equations. Sure, just ask. I mean, let me know. And I've been, I kind of made some posts as far as some ways you guys can promote. I mean, it's always difficult, for me to be able to confirm when I can stream. And I've always been kind of looking at some ways to do this. But, one of the ways maybe I can, look into this is getting, I kind of changed over some of my Facebook groups to have people start promoting, some stuff where you guys can kind of ask the questions, because I know on the live streams here, it's difficult. Like if you have just a picture of what you're talking about, or if you're trying to do math type, it's really difficult to be able to write that in there. So I apologize for that. Cool. Are these quizzes available prior to the live? This is my first live. Well, hey, Ashley Nicole. No, these quizzes are... These are quizzes that I give in my class, so they are not available to you guys before the quiz. So because I basically do the lives as I am teaching, I pretty much prepare the work and then obviously give out homework and quiz answers, and then I go live with the answer solution. So what this does is this allows me, the reason really that I like to go live is obviously, this gives me an opportunity to work through the material and kind of explain it. So therefore, for my students or for any of you guys that, want to kind of see how to do these problems, you guys can go ahead and see it. It also allows me now to have a PDF that I can provide to my students. So let's say a student was out the day that I passed back the quiz. They want to see the answers. They now have a PDF version that they can, basically have as well as take home. And then if they want more of an explanation, they can either come and see me personally, or they can go ahead and watch the video. I also do the live just because I like to kind of check in with you guys that have been really kind of, watching my videos and getting help from me. I want to make sure that I'm here for you guys. If there's anything else I can, kind of answer. It's kind of difficult a lot of times when I do things a little bit later, obviously, because, my time is a little restricted. So I'm not able to always get to some questions and so on and so forth. So Kendall Little, hey Kendall, says, will the stream be posted to your channel once you're done? I saw this late, so I missed most of it. Yeah, yes, no worries. I won't have... So yeah, the way that the channel, or at least the live streams, are posted is that once I'm done with the stream, it automatically gets posted on my channel. And the easiest way to find it, because it does take a little while for it to buffer, so I can't take it immediately to my website, which has always been kind of a difficult thing for me to stay on track of. But what you can do is if you go to my just main channel and you scroll all the way to the bottom, it will have updated live streams, or most recent live streams. And that's where all the live streams. So once I'm done, probably when the next, I don't know, depends on 10, 15 minutes, this live stream should be available for the replay. So hopefully that kind of helps you guys out. Diego, you can rerun the stream just like you run a video. Yes, that is correct. Yeah, you can just also go back late and just kind of cover whatever problems you want to. Works as well. Joe Cadella, hey, you're awesome. You help me with your math problems, your videos. I'm going to do some math homework now. Awesome, Joe. You got it. Rockman, college algebra as a headlock. Man, I hated college algebra. I liked college algebra, but I didn't really appreciate it when I took it. I think when I was taking college algebra, I was still kind of struggling with math, so it was not a fun course for me. just because there's so much math and so much algebra, and especially if somebody that's like not very good at doing like a lot of algebra problems, it's like crazy. You're doing so many factoring problems, so many solvings and all these type of problems, and it was just like overwhelming. So I'm glad a lot of my videos, even though I don't teach college algebra, obviously a lot of my content is translated, you know, and helping you get through college algebra. So I like that. Well, awesome, Ashley. Very happy to be able to help you out. And yeah, you know, one thing too, I mean, just mention, you know, for those of you that, you know, want to go and see, you know, these, like I do have these documents as far as my quizzes, my homeworks, my guided notes, my investigations. Obviously, those are things that I have created and provided to my students. And obviously, if that's something that you're, you know, interested in, I do, you know, have those as a kind of sponsorship thing, platform. And the reason why I really offer that is because it does take time. If you guys have seen, you know, there's some mistakes. I gotta going through hiring people to be able to edit them, as well as to kind of peer review them. So all that kind of stuff kind of takes some, you know, time. And obviously I'd like to provide these resources to more and more people. So the more kind of resources that I'm able to build up to kind of professionally redo a lot of these documents, you know, the more I feel like I can kind of expand as far as a lot of the stuff that I'm creating, or a lot of the ideas I have. So before I get to going on thing, I am so sad in it. LOL. Grim. I know. I got you, man. I totally feel you. I know exactly how it is. The main thing is, you know, the one thing I did find about college algebra when I took it is it's a lot of the same thing over and over. And so what you really got to do is kind of grasp these main ideas that keep on reoccurring over and over. And I think once you're able to like identify some of those basic concepts that your instructor is just going over. And to be honest with you, this is just really, you know, the same thing with any math class, is identifying a lot of these common themes. Because you're going to, and actually not even any class, it's like any class that you're taking, there's always going to be these recurring themes. There's always going to be these patterns. And I think that's the, you know, I think that's a theme with a lot of classes is, you know, looking for the general scope of the idea, a lot of the, you know, main arguments that we are really tackling with each course, and identifying those patterns and then keep on building off of that. So, Brian McLogan, it's not the real me, guys. This guy is an imposter. Well, how did Brian McLogan show up on my channel? What's going on here? I don't like this. That's not very funny, Brian. All right, guys, I'm going to go ahead and sign off. 37 minutes so far, so I think that has covered it. Obviously, guys, if you have any questions, feel free to respond back in the chat. I will go ahead and, you know, just reply just for a little bit. And otherwise, I will look forward to seeing you guys next time. Just to let you guys know, let's do a little housekeeping again. Let's see. I will. Oh, that's my screen. Oops. There you go. Let's see. We're going to start our new unit on trig next week. So I will be probably going live again, probably looking into like Tuesday and Thursdays of next week over trigonometry. So if you are in trigonometry, or you're going to be coming into trigonometry, or you just want to get some help with some trigonometry, that's what we'll be covering next week. So look forward to those videos coming to you guys soon, and I hope you guys have a great rest of your evening, and I'll see you guys next week. Cheers.